Okay, here's a very brief intro into long division in algebra. So let's just take it as most basic. If I said 3 is a factor of 18 and I want you to find the other factor. If 3 is a factor of 18, they're telling me it divides into 18 with 0 remainder. So 3 into 18 is what we're doing. So 3 into 18 goes 6 times. Once I found that out, I multiply back down. 6 times 3 is 18. Now I subtract my top line from my bottom, and remember I said you could just remind yourself, just change the sign. 18 take 18 is 0. That means I'm finished. So this is my other factor. 6 is the other factor. Now, let's just involve a bit of algebra. X is a factor of x squared minus 3x. Find the other factor. If it's a factor, I know it divides in with 0 remainder. So I divide x into x squared minus 3x. So what do I multiply x by to get x squared? I'd multiply it by x. And I multiply that back down. X times x is x squared. Now, I subtract the top line, or the bottom line from the top. And I do that just by changing my sign. X squared take x squared is gone, 0. Okay, I don't bother writing down that 0 though, it's just gone. But what have I not used? I still haven't used the minus 3x. So now I begin all over again. X multiplied by what will give me minus 3x? Well, minus 3. And now I multiply back down. Minus 3 multiplied by x is minus 3x. So now I'm going to subtract my bottom line from the top, and I do that by changing my sign. Minus 3x plus 3x is 0. So I have 0 remainder. That means I'm finished. So x minus 3 must be the other factor. Okay, so that's just a very simplified example of long division. Now let's just do one that's a little bit more complex, but we're following the exact same steps. Now in this third example, we've got a new word, root. Okay, now we talked about that in class, but just remember, if you have a root, you're able to find a factor from it. So x equals 5 is a root of x squared minus 9x plus 20. Find the other root. So remember, x equals 5 is a root. But I'm not so much interested in roots for long division, I'm interested in factors. So if I have a root, I know that if I bring the root over, it will create a factor. X minus 5 equals 0 is a factor. So this is the part here I'm interested in, the x minus 5. If it's a factor, it must divide in with 0 remainder. So I go to divide it in. Leave me with x squared minus 9x plus 20. So, what do I multiply x by to get x squared? I multiply it by x. Then I multiply back down. X times x, x squared. Those should always match. X times minus 5, minus 5x. Lovely. Now what I'm going to do is I'm going to subtract my bottom line from my top line. No harm in just writing in, changing the signs, and it stops you just making a silly error. But all you're doing is subtracting the bottom line from the top. X squared take x squared is gone. Minus 9x plus 5x is minus 4x. Brilliant. Now I can bring down my plus 20 here. Bring down the next thing. Okay, and we start all over again. X multiplied by what will give me minus 4x? Well, I'd have to multiply it by minus 4. So let's multiply back down. X times minus 4 times x is minus 4x. Those should always match, remember? And then minus 4 times minus 5 gives me a positive 20. Okay. Subtract the bottom line from the top. And remember the easy way, change the signs. Minus 4x plus 4x is 0. And 20 minus 20 is 0. So I've got nothing left at the bottom. That means I'm finished. So x minus 4 is my other factor. But I don't want the factor, I want the root. So x minus 4 equals 0. That is my factor, and just like solving the end of quadratics, bring your minus 4 over to get a positive 4. So x equals 4 is a root. Those are the fundamentals of long division in algebra, and we'll be doing cubics the next day.